I take immense pleasure in inviting the participants to this concluding session of 3 days hands-on workshop on Latex. I welcome our Honorable Resource Person, Dr. Sriram Alladi, to this workshop. Now I request Dr. Sriram Alladi, sir, to take over the session.
Yeah, so I think I'll share my screen first. Yes. You can see my screen.
Yes, sir.
Yeah. You can see that I'm logged into Overleaf. Okay, so one request that came up yesterday was about how you use LaTeX to draw diagrams or figures, right? And so maybe I'll touch upon that briefly today. So I'm not an expert on this myself, so I won't be able to talk about this in detail. But if you want to talk about, if you want to draw diagrams in LaTeX, there is this package called Tix. So you can see that there is a prompt for Tix, right? And in particular, a lot of us are interested in drawing graph theory, right? Like a lot of people like do research in graph theory, and they'd love to draw graphs, right? And like doing this with Word, I think is almost impossible. So maybe you'll have to like uh, draw your graphs manually, or maybe use like PowerPoint. I don't know what people do, but then one option is you can use Tix. And Tix actually provides a library for drawing graphs. And this is not the only solution, by the way. So what you do is there's a library in Tix. So you will have to somehow invoke that library. Graphs. So I'll just make a comment here. And this is used for drawing graphs in LaTeX. And then another library. Let's use this. And there is, I think, something called standard dot graphs. Okay, we'll come to this. So let's see how to draw graphs using this tool. So let's make a section on drawing graphs. I compile this. Okay, one second. Let me minimize this. Yeah. And let's draw like a very, very, very simple graph. Like just one edge. So you have to invoke this library called graphs, and this is the command for it. And here, so Tix, and then graphs. Like what I'm going to do is just draw a graph with two nodes. And let's just run this and see if it works. There's a mistake. So there should be graph only single. So you see, It just gives you a graph from 1 to 2. Okay. So let's see, suppose we want like, and this is a directed graph, right? But then what might happen is you might want like a, so this will give you a graph from 1 to 2 and 1 to 3. So now this is a directed graph, but what if you want an undirected graph? So then what you do is you don't have the arrow. So this gives you, so this is the like um, this is the node 1, and then you have, you're drawing from this, you're drawing two edges to 2 and 3, and they're not directed, which means you can go in either directions. But from 2 to 3, um, so from 2 to 3 there is a directed edge pointing away from 2 and then towards 3. Okay. So there are a lot of things that you can do with this. Maybe you can color this. I'm not sure if this will work. Yeah, but then you can even label it, and there are a lot of things you can do with this. So let's not go into that. But then often what happens is you have these standard graphs in graph theory, right? So one example of like a very common graph that we study in graph theory is the complete graph with n vertices. So let's see how you would represent that. That is Kn, right? And the complete graph means like any two vertices, you can there is an edge between. And how do you represent that? So for this, there is actually a macro, and we need to like include a library here. Graphs.standard. So maybe it is already there in graphs. But I like including this is not going to do us any harm, right? So now what I'm going to do is like let's draw a complete graph. So this is the command subgraph. So if you have taught a course on graph theory or you've taken a course on graph theory, usually the notation for the complete graph is Kn. Let's say n equal to 4. And then let's label all the vertices clockwise. And these semicolons are actually very important. So usually, if you've followed our discussion so far, we generally don't use semicolons in ordinary LaTeX code, but somehow in TIX code, we have to use semicolons. So you see, this is like a complete graph. So it does what it's supposed to do. And so one thing you might not like here is like you'd like the nodes to be circles with these labels inside the circle, and that can be done. But I'm not going to go into that. So if you want, let's slightly modify this example. Let's say n equal to 6 and clockwise. And we just compile this. Most likely it's going to show an error because
Excuse me, sir.
yeah,
Sorry for the interruption. Sir,
yeah.
how to draw an unlabeled graph, sir? Instead of this 1, 2, 3, 4, how to draw just
No, I
vertices and
think
edges?
by default all your graphs will have to be labeled.
Okay, sir.
Yeah. Or
If you
maybe you
want,
can use circles instead. But I'm not
yeah.
actually sure. Most likely, I think this library assumes that you're going to your nodes are all labeled. Okay.
Okay, so now let's compile this. There is a mistake somewhere. Yeah, the mistake is some reason it's not compiling this. Just 1 second. Let's change this here. Save it. Then compile it. So you see, like you get what you're supposed to do. So now you have the complete graph with 6 vertices, but you don't have to use like 1, 2, 3, 4, 5, 6. You can use different labels as well. And someone wanted graphs that are not labeled. You can do that, but I'm not sure how. So another standard graph that we draw is if you're and using this you can actually draw like other graphs. So let's see. Suppose let's say we want to draw a graph. So you know what the cyclic graph with n vertices is, right? It's just one cycle, right? And there's exactly one cycle joining all the vertices. And what I can do is say we have 4 vertices. And we want to like list them in the clockwise sense. And then now suppose I want to introduce a new vertex in the middle. So what I can do is I can call this the central vertex. Yeah. It's flagging an error here. So let's see the error message. So it looks like I've forgotten. Yeah, I keep making this mistake. So like you have to keep in mind that this is not a subscript 4 in the sense of ordinary LaTeX. Like I'm used to that by default. And so now things might work. Still showing an error. So let's see. There is some dangling bracket somewhere. Okay. Yeah. Someone wants to access. So someone wants to access my screen. Yeah. Does someone have a question? Let's see. Maybe I need a semicolon here. I don't see what's the mistake. Uh, Write this here. So you see, you're getting. Yeah. So you have like a subgraph. This is K4, and let's make this Cn. Yeah, this is right. So you have Cn, so C4 with 4 vertices, and so now you've introduced an additional vertex called mid, and what is happening is like these are like then you draw like edges from all the other vertices to mid, or you can call this center if you want. So it's actually quite flexible. Okay. Are there any questions? So let's see. Another important graph that comes up all the time is the perfect bipartite graph. And let's see how you draw the bipartite graph. So I'll make a comment here. So this is the standard cyclic graph. With an additional node at the center. And then this is like some random graph. And now let's draw another standard bipartite graph. So again, what you do is you invoke the same library. Graphs.standard or graphs. Fix graph. Then what I'm going to do is subgraph. So first, let's take vertices. So like what I can do is, if you know what the bipartite graph is, so you have like you partition the vertex set into two sets, right? And like within those two sets, there are no edges, right? And then you have the complete. So that is I think, a bipartite graph. Like, correct me if I'm wrong. And then complete bipartite means you take any edge and you take any vertex in one of these sets and any other vertex in the other set, then there is an edge which is connecting them, right? So you can partition the vertex set into two sets, X and Y, and then between a vertex in X and a vertex in Y, there is always an edge. That is the complete bipartite graph, I think. So now let's try to like sketch the complete bipartite. So what is the notation for this? I think KNM is something that we use, right? Just 1 second. Yeah, let's do this. So you can use three vertices A, B, C, or let's say 1, 2, 3, and then complete bipartite. And let's say 4, 5, 6. And that's it. So let's see. Let's run this code. Some reason it's not running VM. Okay. So use sticks library graphs 1, 2, 3 complete by fabric. Okay, so it lists 1, 2, 3 and 4, 5, 6. But unfortunately, what's happening is it's not actually yeah. So this does the trick. So 1, 2, 3 and then 4, 5, 6. So you have, so the vertex set is 1, 2, 3, 4, 5, 6, and then so you have partitioned it into 1, 2, 3 and 4, 5, 6, and then from everything in one from a node in one the set 1, 2, 3 to a node in 4, 5, 6, there is an edge. And of course, this doesn't look good. If you want, you can enclose the uh, nodes in circles. That can also be done. But you'll have to look at the manual for that. So this is an example of a complete bipartite graph. And if you want to, what you can do is, let's do something here. Say you want to now draw an edge between 1 and 2. So this, then let's say you want an edge between 4 and 6. So, but now the problem is that so somehow this is not proper, right? So because it's passing through phi, and you'd like to like draw it properly. So I think what you can do is I think the syntax is bend right or bend right. Some reason this is not working. I maybe don't remember exactly what you should do, but what you can do is you can draw a curved line from 4 to 6. That's also possible to avoid such like intersections. Maybe let's try this. So I probably don't remember exactly what we should do, the exact command for it. So there are a lot of things. It's quite a flexible tool, and unfortunately, my knowledge of this is quite limited. So, but if you want to draw graphs, so if you're a researcher in graph theory, then like it makes sense for you to get familiar with the TICS manual, right? So there's a manual for TICS, and you can just access this by googling, and it's a long manual. But my advice would be like if you want to do something, you just Google it and read the appropriate portion of the manual. That should help. Okay. So are there any questions about this? Okay. And by the way, there is another tool that you can use, right? So there's a package called TKZ Purge, right? So this actually gives you um, helps you to draw most of like the standard graphs. For example, one graph that comes up a lot is the Peterson graph, and you have like code for that available. So there's a macro, and then if you invoke that macro, it will draw the Peterson graph. Okay. So my knowledge about like graph theory and about like using text to draw graphs is actually quite limited. So I think I'll stop talking about this topic here. So like let's like proceed to like a different topic. Uh, so if you're writing a paper, yeah. So there are some comments here. They want me to share the LaTeX file. Okay, I'll do that. Uh, Yes, so like one thing, like many of you are like research students or like researchers, and so one thing you would often do is you'd be writing papers, right? If you're doing your PhD or you're an active researcher, so then you'd have to actually provide citations to all those papers that you're referring, right? And so one tool that we can use for this is BibTech. So I'll go to my browser now. And let's go to Google Scholar. I think I'm logged in. Yeah. So let's type like our topic. Okay. So so LaTeX. Uh, okay. So now what I'd like to do is, I'd like to cite all these, like, provide a citation to these articles or books. So what I'm going to do is I'm going to save them. So I've already saved 3. So let's save all these things. Just randomly saving a few articles. So I've saved some. So let me just go back. So what I'm going to do is go to my library. And now what I can do is, so these are all the things that I've saved, all the articles that I've saved. So now I can export all. Or export all. Yeah. So what it does is it gives you like a sort of BibTeX file. So let me just go again in case you missed it. So export all BibTeX. And this file that they have given, it's not a LaTeX file, it's a BibTeX file. So each entry here is like a database entry. So what I'm going to do is I'm going to copy paste this. And let's go back to our original. So I'll open a new file. So let's call it references.bib. References.bib, sorry. All my references are going to go in this file. And let's copy paste everything here. Let's go to the main file. And here what I'm going to do is put this. So I'm going to type a bibliography style, plain, and here references. Let's compile this code. So I have to compile this also. So maybe you need to do this a couple of times. This is one unfortunate thing. Sometimes it doesn't happen. And if you compile this, you'll get all the references. Okay. Yeah. So why is it not showing up? The reason it's not showing up is not because I've made an error, because like I've not actually cited any of the articles. So for that, what you have to do is you type this command. I think it's no cite. And now if I'm correct, it should work. Yeah, see, it's showing up. So let's go back. So you see all the references are showing up. You do not, so the advantage here is you do not have to manually enter all this, right? And now Google Scholar actually makes our life really convenient. It used to be the case that like before Google Scholar, we would have to actually like manually create this BibTeX file, and that process was error prone. But now we can just import everything from, or rather export like all the references using Google Scholar, and then just copy paste it, and then like generate references in no time. So let me just switch to PDF, and so you see here. So these are the references, right? So if one defect here is maybe they're not in alphabetical order, so and that is because I'm just using plain style. But if you want to, you can change that as well. So there are a lot of styles here. Alphabetic. So let's try this. And sorry. Uh, so a lot of styles here. So let's say you want to sort this by author year. I don't know. I usually always just use plain, and it just works. I'm not familiar with it this time. See, author here, why is it not like this? Maybe we should include some package. Yeah, I think we have to include some packages. So let's just stick to this. And so the nice thing is you have all your references. Okay. So what we can do now is let's see how to cite a particular article. So let's say I want to cite this. This is a book, Helmut Kopka and Patrick W. Daly, or Daly Latex. So let's see how to cite this. So for more on the subject, so cite. So the prompt will give you everything. So Kopka, let's say 2004. Yeah, so you see here, it gives you a hyperlink. So if I click on this 5, it takes me to a 5. And if you want, you can include other references. So what is this Kopka 2004 latex? That is the label that is included here. So you can see here, this is how you, so when you want to cite an article here, so references. So you see of the site, this is the citation label. Yeah, so this is the citation label. Kopka 2004 LaTeX. If you want, you can change this. Right? So you want to cite, you just type /cite and Kopka 2004 LaTeX, the bracket, and that's going to give you the citation. Okay. So are there any questions about this? So the nice thing is all of you have access to Google Scholar, and you can just like import or export all the references to a file. And then just copy paste that, and you just need to remember these two comments. And this is so that the references are shown up at the end. But I think you can also provide references at the end of each section. So let's say you want references here. So this is another file, the end of a section. Then you can do that as well. And let's run this. Yeah, so the references show up at the end of each section. And in case you're writing a thesis, sometimes you'd like to have the references at the end of each chapter. And that can also be done. Okay. So are there any questions about this? No? So next, like one very important thing. So far we've talked about how you typeset an article, some basic LaTeX, then how to include it references, and then also how to draw some diagrams. Though I haven't discussed that in detail, it's not my strong point, as you may have noticed. So like the next thing that we're going to talk about is so many of you, like as students, might go to some like conference and you might have to like present some of your research, or if or maybe you're a teacher, and so like nowadays like hybrid modes of teaching are really popular. So like some sessions you have a lecture in class, and then some sessions like are conducted online, right? And some colleges allow this. So in case you have an online session, um, like you'd like to prepare prepare a presentation about what material you're covering, some slides, and then one way to do this is using LaTeX. So there's a package called Beamer uh, that will help you like prepare presentations. So I'm going to discuss Beamer today. So let's just go back to overview, or sorry, overleaf. Start a new project. Sample presentation. So here it says the document class is article, but what we are going to do is we're going to change this to Beamer. And now what I'm going to do is Beamer has many themes. So I'll use, let's say, the Singapore theme. There are like many of the themes are named like after cities. So but there is also default. So let's use default. This is the default theme. Begin frame. So again, everything has to include, like every LaTeX file has to include a begin document and end document. And then you also have sections in Beamer, but then you also have frames. So it must contain a begin frame and an end frame. And let's type something here. So a sample presentation. Most likely it's not going to work. Okay, so it gives me a sample presentation. So you see you have slides. Okay, so if you want, this is a sample presentation. So what I can do is what is Beamer? So I can include a block here. So what is Beamer used for? Beamer is used for making sample presentations. So this is a block, and so sometimes you'd like to put this in a box. So one way to do this is default. You don't have that option, but let's use a different theme. This one. So you see. So this could be a question, and this could be like some kind of explanation. So suppose you're trying to like explain a proof. In frame, and frame. And so each frame has a heading or a title. So let's give a definition of some, the least of it. Okay. So now what you can do is begin a definition. You can block, block. On this definition. So let A be a non-empty set. Subset results. So we say that L is the least upper bound. if, so now what we want is, we want to list 2 points. The first point is L has to be an upper bound. If U is an upper bound for A, L is less than equal to A. So now one issue comes up. So you'd like to sometimes what you can do is you'd like to explain this point by point. So what I can do is I can pause this. So then what happens is the first point shows up in one of the slides and the next one shows up in the other slide. So the thing is that when you make presentations, you shouldn't include a lot of information. Okay. So too much information means like too much things to process and people are going to get lost. Right? So you include like a pause here and so that will break it up. So just to explain what's happening here, let's just create another thing. This is a quadratic equation. So you can use the equation mode. Where ABC is and A is 1. So one problem that every block must have a heading. Like then you also have theorem statements. So every frame must have a frame title and you can theorem. So the roots of the quadratic equation are given by begin equation star square root of b squared minus 4ac. So let's see. So you see, labels it as theorem. And if you want, maybe you can include the title of the theorem here. So this might seem very intimidating. You have to remember all these commands, but with practice, you will be able to do it. So now, when you make a presentation, you'd first like to present an overview. So what you can do here is the command for this is overview. I'm not sure. Table of contents. Yeah. So this will list. So we call this over. So table of contents. So this will list all the sections. So for example, so my first section is introduction. Let's say the second section is sample presentation. It won't list all the individual frames. Stuff like that. Make additional sections for writing equations. Let's combine this. So you see, you have hyperlinks. So to click on that, it will take you to the corresponding section. Okay. So are there any questions about this? No. Let's look at the chat box. Yeah.
Fluid dynamics.
Okay. Fluid dynamics.
Somebody is doing research in fluid dynamics and they want to know how to type governing equations in LaTeX.
How to type?
Equations in LaTeX. Governing equations.
What equations? Can you just type it in the chat box? Zoom meeting. I think there's a chat. Let's look at the chat box. Yeah. Okay. How do I type governing equations in LaTeX? Okay. First of all, I have no idea what the governing equations are, but let's Google it and look it up. And I'm sure I'll be able to. For some reason, keep showing this. How am I going to get rid of this? Governing equations. Fluid dynamics. So let's go to Wikipedia. There's no particular equation that is mentioned. Which equation is it? Is it this equation? If you can send me a picture of the equation, then that would be helpful because I don't know what the governing equation is. Because once I see it, I'll be able to just send me a picture or like, I don't know what exactly the governing equations are.
Miss Barakatulisa, can you
Yeah.
please explain your query to sir? Miss Barakatulisa?
Yeah.
I said governing equations, I'm doing fluid dynamics, hybrid nanofluids, sir. Equation, momentum equation.
So some of your voice is not very clear.
Sir, I'm traveling now for the time. This audio is clear.
Okay. So you're driving now.
Yes, sir.
Uh-huh. No, but I don't know what exactly the so you can see my screen, right? So I've opened this article on the governing equation, and like I don't know.
Sir, for the differential equation, how we type
Okay,
Latex, sir.
you'd like to type differential equations.
Yes, sir. Yes, sir. Yes, sir.
Okay, okay. So let me just.
Partial differential equations.
Okay, yeah, it's actually not that difficult. So let me show you how to do it. So like, yeah, in this itself, maybe I'll open a frame, create a new frame here, section typing partial differential equations. So let's say, the Laplace's equation is the most famous like partial differential equation. So label it as Laplace equation. So Laplace's equation is del squared u by del x squared plus del squared u by del y squared plus del squared u by del z squared equals. We're looking at the three-dimensional Laplace. So you want to write this as an equation. So you create an equation environment. And so del squared u by del x squared, so this is a fraction. Partial squared u. So, okay, so let me just explain this code. So if you think about, forget about the mathematical meaning of this. So if you want to type this, it's essentially like typing two fractions, right? So just look at the first one. And so del squared u by del x squared. So this is like a like typing a fraction. The numerator is del squared u, the denominator is del x squared. Of course, like we know that it's not a fraction, but to type it, we just need to type it like how we typeset a fraction. Okay, so then how do we type the numerator? So we need a symbol for we need to know how to type del, and del is not available on your keyboard. So the way you like type a del is a backslash partial. Okay, and then we need to raise this to power 2. So then we have this symbol, and then in brackets we have 2. So partial squared u. And then in the denominator, we have partial x squared. The same thing. So partial for del, we have partial, and then x squared, we know how to type. And then plus fraction, partial squared u, partial y squared, and the same thing. And the symbol for plus is just plus. So this is Laplace's equation. If you want, you can label it. So similarly, what you can do is you can type the heat equation. So partial U, partial T. The good thing about over U, it will give you like a preview of what is happening. So you see, like it's showing you what you expect, what you like, what you want to type. And this has to be. So if I'm back partial uh, partial squared U, partial x squared, let's frac partial squared U, partial y squared. So the heat equation. And you can label this so that you can refer to it later. So I hope that answers your like question as to how to type like equations.
Thank you, sir.
Yeah. And it even numbers it, and if you want, you can refer to it later. Okay. Any other questions? So like another thing you can do is you can use font, maybe sans serif. You can change the font as well. Not the right command. I don't remember the right command, but yeah. So you can change the font, you can change the color, and there are like many other themes. So for example, there is this theme called Warsaw. Yeah, and this is the theme. It has like a different, so all the themes are named after cities. Somehow this is not the right theme. Michigan is another theme. And each theme has its advantages and disadvantages. Michigan, Berlin, I think. Yeah, so this is one thing, Berlin. Amsterdam, I think I've used this before. Okay. Can't remember everything. Or you can create your own theme as well. Or just I always use a default. I don't like all these boxes. And it's just a plain theme. Yeah. So are there any other questions? No, I think because I've talked about a lot of stuff. I've not covered anything in detail, so I like if you ask some questions. So someone is asking something in the chat. Okay, so let's just review like all the topics that we have done so far. Just a brief review. So so a couple of things. So far we have used overview, and overview is good enough like it's good enough for everyone, right? But sometimes you might want to install LaTeX on your computer, and for that, what you have to do is you have to install a distribution called MikTeX, right? You just Google MikTeX. If you're using a Windows computer, you go to MikTeX, and you can see there'll be like you can install MikTeX here, right? And you can so download MikTeX, and you just check if uh, look at your corresponding operating system, Mac, Linux, Docker, Mac, Linux, and then just download it, and you can like run the installer. And then you'll also need a LaTeX editor, right? So in my case, I use something called Tech Shop, but like there's another thing called Tech Maker that is very popular, and for some reason I could not like install it on my computer. And so once you like click on this is an editor, and you can like edit like type LaTeX code on this editor and run it. So for example, let's say this is how like a sample LaTeX file will look. And then you typeset it, and it generates an output. So you don't have to use overview, but overview I think is very good if you're a beginner. You don't have to worry about all this installation. Once you get used to it, then you can then start using. You can install it on your PC. But one defect is that you need access to an internet connection. And if you don't have access to the internet, then you'll have to somehow install it locally on your computer. Okay, so let's just review what we have done so far. So I have a bunch of slides. So like LaTeX, this is a software system for producing scientific documents. And this is exactly like HTML in a sense. So it's a markup language, right? And it just provides a set of rules that like determine how a document must be presented. Okay, so remember every LaTeX document has to start with this document class command. So this tells us like what type of document we're intending to typeset. So it could be like a thesis, in which case you use report, or an article, or a beamer, or slides. But you have to tell like what type of a document you're trying to typeset. And this thing in square brackets is actually optional. But here I've like written square bracket PDF, which means the output will be a PDF. And then every LaTeX document has to contain this begin document and end document. If it doesn't contain it, it's not going to run. It's not going to produce an output. So in this case, if you look at this example, this is like it does nothing, right? So because it does nothing because there's no content inside this begin document and end document. Like what the stuff inside the begin document and end document will tell us like what's going to happen. So in like the way I've typeset it, so you have this, you see this box here. So the code is on the right and this box is on the left, and the code box has nothing inside it. So like that means this code has no effect. So this is the document class, right? So like, what are the different types of documents you can create using LaTeX? So article, book, slides, report, beamer. Report is in case you want to like prepare a PhD thesis. And many institutions these days, they'd like their thesis to appear in a certain format, right? So they'll provide like a sample a thesis template. And so later code is just processed from left to right, just like Word, right? And if you want to like skip go to the next line, then you have to leave one blank line. So you can see in the code that I've given on the right, so there is a blank line, and the effect of that blank line is this then line after stuff after hello latex is moved to the next line. But two blank lines just has the same effect as a single blank line. And like another thing that we talked about is like if you want anything after a percentage is actually ignored, right? So any stuff after a percentage is ignored. So if you sometimes you would like to like explain what your code is doing, right? If you've done programming, this is like a common practice. And so you'd like to comment about what your code is doing. So for that, you use percentages. And that will not have any effect on the document because anything after a percentage is just ignored. So you can see. And if you want to type special symbols like dollars, percentages, etc., backslash percentage. And that will give you the percentage symbol. Okay. So then the third example that we saw is you want to type lists. So for that, use the begin itemize and end itemize environment. And then within that, each entry in the list, you use a slash item, backslash item. And if you want like ordered lists, you have to use the enumerate package and then use begin enumerate and end enumerate. And for tabular columns, we saw that you just use begin tabular and end tabular, and you have to specify how many columns here and the layout of the table. So this is the code. I'll actually share the code and maybe share the code with the organizers, and then they can probably like post this document somewhere so that it will be useful for you. So this is like the syntax of begin tabular and end tabular. And the important thing about LaTeX is typing mathematical expressions. And you want to type a mathematical expression, it always goes within $2. So yeah, we have discussed all these examples. And then you have the begin equation and end equation environment. Even today, we are typing equations. And then you can also label equations and refer to them later. And similarly, yesterday I talked about the way we can the theorem and AMS theorem package, where you can label provides an environment for theorems and proofs and examples and so on. And so then you can create labels for them and you can refer to these theorems later. And that's about it. Actually, so my advice is um, initially there will be a learning curve, and it's quite steep actually. But so my advice is you don't have to read any book. So let's say you want to typeset like a partial differential equation or some like some symbol, right? So you just Google and then just look it up and then just try it out on your compiler and then see, and then with time you'll get used to it. So that's what I do. So if I don't know something in LaTeX, I just Google it, and so I invariably like whatever I want is available online, and then I just run it, and so then later I just modify it according to my specifications. Okay, I think we can stop here because I've run out of content actually.
Sir,
Yeah.
sir, there is a query. A participant is asking how to reduce and increase the length and width of a figure.
The length and breadth of a
Figure
yes,
that
yes,
is
yes.
drawn.
No. So the thing is, off my head, I do not know the answer to this. So you can use the TIX package, and like there you can actually specify like the dimensions that you want.
Okay, sir. Fine,
TIX
sir.
manual actually like has all these details.
Yes, sir. Yes, sir.
Yeah. So you'll have to refer to the manual. Like it's a daunting thing. So yesterday I was actually looking it up, and it had a lot of information. But like what you can do is you can just Google and see like how you do it, what the command is. You don't have to remember everything.
Yes, sir. Thank you, sir. Thank you, sir.
Yeah. See.
Thank you so much for the informative session, sir. I'm confident that this presentation will assist emerging research scholars and faculty members in grasping the fundamentals of the LaTeX tool. Now I request the participants to clarify their doubts, if any.
Good evening, madam.
Yes, sir.
Hello.
Yes, sir, you
Hello.
can talk, sir.
Yeah.
Kindly share that PPT. All of us, they can utilize that coding for their own research purpose.
Yeah. I'll share whatever slides I have.
Okay, sir. Thank you, sir.
Yeah.
And one more thing, here we can possible to draw that plotting that graph is possible.
Yes. You mean like ordinary graphs? Like what kind of graphs? Like not graph
That 3D graphs.
Yes.
Three-dimensional graphs.
Yes. There is a package called PGF plots. So
PGF graphs.
so maybe
Okay, sir. Because I'm in the field of fluid dynamics, I wish to use the three-dimensional graphs,
yeah. PGF plots will
and
help.
that particularly I'm asking. And also one thing, sir, can you share any research article format is there? Because I'm using that Text Studio. While I'm downloading any format, it's not acceptable, and while I'm running now, it will get that error message.
No,
That's why
my
I'm asking.
suggestion is you can use overleaf, but yeah, text.
Oh,
So I think probably like you haven't configured your settings properly. So you can try
okay,
some
okay.
other
Sure, sure.
thing. TechMaker is something that is usually quite good, but it's possible that somehow
Oh,
you can try to reinstall Tech Studio. You can troubleshoot this online actually.
oh, okay, sir. Which one is that text maker or text studio? Which one is the better one, sir,
They're
to
all
making
quite
that latex file?
they're all quite good. I liked a TechMaker, but somehow on my PC I could not
Oh,
install. So I'm using something called Tech Shop.
oh.
They're all
Both are I'm installed, sir, in my PC.
okay.
That's why I'm asking, sir.
Yeah, TechMaker is quite good. Like all of them are quite good.
Oh,
You can also
okay,
use
okay.
an ordinary ordinary editor also, but like LaTeX editors are quite good. They provide highlighting and other features.
Okay. Sure, sir. Thank you for your valuable
Yeah.
response and clarification my doubts, sir. Thank
Yeah.
you.
So I thank Dr. Sriram Alladi sir for sharing his knowledge with us. Now I call Ms. Tahira Banu, Assistant Professor, Department of Mathematics, to render the vote of thanks.
First and foremost, I thank God, the Almighty, for making this workshop a resounding success. On behalf of the Department of Mathematics and Statistics, I express my deepest gratitude to the management, Sri Shankarlal Sundarbai Shasun Jain College for Women, for providing us a platform to learn collaboratively. My sincere thanks to the Principal, Dr. S. Matpavati ma'am, Vice Principal, Dr. S. Rukmani ma'am, for rendering their support to organize this hands-on workshop on LaTeX. I thank Dr. M. Kamalam, Head and Associate Professor, Department of Mathematics, for her meticulous follow-up on the progress of this workshop at every stage. Our special thanks to Dr. Sridevi, Director, IT team, and the technical assistant team for their seamless support in relaying this program live on the YouTube channel. Our special thanks to Dr. Sriram Alladi, Assistant Professor, Department of Mathematics, Agurchand Manmul Jain College for Women, for sparing his valuable time and knowledge with us during this 3-day virtual workshop. The session was highly informative and it gave us a deep insight into the fundamentals of LaTeX. The patience, clarity, and the ease with which you explain the complex concepts inspired all of us a lot to learn more about LaTeX. We deeply grateful for the time and effort you invested in us for this workshop, sir. I express my heartfelt thanks for stretching yourself by touching upon the topics that were not in the agenda to address the queries of the participants. Thank you, sir, for taking us through this pleasant, informative, and an engaging journey. Last but not the least, I thank all the participants across the state for their active involvement and participation in all the sessions. We will all remember you with gratitude for your contribution to this workshop, which is very important to its success. The workshop was a resounding success, and I appreciate the effort you put into making it a valuable learning experience for all of us. We look forward to organize more such workshops in the future. Thank you all. Participants are requested to fill the feedback posted in the chat box.
Sir,
Yeah.
thank you so much, sir.
Yeah. Can I log out?
Yes, sir. We can log out, sir.